on page... Okay, so this is the example on page 73, example 2. It is example 2. So we have the equation y equals 2.75x represents the rate in barrels per hour that oil is pumped from well A. The graph represents the rate that oil is pumped from well B. Which well pumped oil at a faster rate? So we're going to use the equation y equals 2.75x to make a table. So our x was time, and our quantity was y. Get that from our graph here. And in 1 hour, we pumped 2.75 barrels. Well, in 2 hours, all we have to do is 2 times 2.75 and get 5.5. In 3 hours, we're going to do 3 times 2.75 to get 8.25. And the same with 4. 4 times 2.75 is 11 barrels. So then to find out our barrels per hour, we do our y over our x. We see that's constant. And well A can do 2.75 barrels per hour, which also happens to match our slope. The first one we need to find the slope for our graph here. So we're going to do 0.410 up here. We do our y over our x, and we get 2.5 barrels. Well, we can see that, or we could have done rise over run, and solid also. And we compare the two slopes, and 2.75 is greater than 2.5. Therefore, well A is pumping more faster because they are doing 2.75 barrels in an hour, while the other one is doing 2.5 barrels in an hour. All right, we're looking at the your turn number 4. So let's look at it. The equation y equals 375x represents the relationship between x, the time that a plane flies in hours, and y, the distance the plane flies in miles. So for plane A. The table represents the relationship for plane B. Can't speak. Find the slope of each graph for each plane and the plane's rate of speed. Determine which plane is flying at a fast rate. So I'm going to make a table for my other one. So I'm going to label this. This is B, I believe. Yep, this is B. So I'm going to label it because I'm a visual person. This is plane A. So I'm going to label it. I'm a visual person. Our time's going to stay the same on top. Our distance is going to stay the same on bottom. So we're going to keep the same breakdown here. We're going to have 1 hour, 2 hours, 3 hours, and 4 hours. So 1 hour, if it's doing 375, I'm going to plug that into my x here. 375 times 1, it's going to be 375. Then I'm going to plug my 2 into this equation. 375 times 2, which is 750. Then I'm going to plug my 3 into this one, and that's going to give me 1,025. 1,125? Is that correct? Sorry, trying to do this in my head. And then we can go ahead and do the 4. 375 times 4, which is going to be 1,500. Okay? So it's asking us to find the slope. Well, 425 over 1 equals 425. So this one is doing 425 miles in 1 hour. While this one is doing 375 miles in 1 hour. So the question is, which one's going faster? Is 425 miles per hour faster? Or is 375 miles per hour faster?
Plane B.
Plane B is going faster because its unit rate of 425 the unit rate in the table, which is going to be the per 1. Because remember, unit rate is per 1 miles per 1 hour. Since it's already in here, all I do is look at my ones and say which one was bigger. That's going to be the faster one. Okay, when we're looking at just the unit rate to see which one's going faster, we need that 1. Or we could look at the slope, which, remember, slope is our unit rates. It gives us per 1. So we're able to compare it there.